Dear students, now we will discuss about crystal defects. So, crystal defects arises in crystals because no crystal is perfect. Crystals are never actually perfect. That's why every crystal structure shows some deviations which are called as crystal defects. So, generally in crystals the defects are classified into two types. One is the defects in stoichiometric compounds and the other one is the defects in non-stoichiometric compounds. First, let us discuss about the stoichiometric defects. Again, the stoichiometric defects are again two types. One is Schottky defects and the other one is Frankel defects. So, coming to the Schottky defects, this type of defect arises due to vacancy at the cation site, which is occupied by a vacancy at an anion site to maintain the electrical neutrality. See, in this diagram, we can show that here a vacancy at the cation site. To maintain the electrical neutrality, we can observe another vacancy at the anion site. See, here the vacancy at cation site, because A plus B minus A plus B minus A plus B minus, here we can observe this is here at A plus. So we can observe that here it is vacant. So one cation site is vacant, and to maintain the electrical neutrality, one vacancy at the anion site can be observed. So this kind of defects are considered as Schottky defects, and generally this kind of defects are observed in ionic compounds with high coordination number, and the positive and negative ions are in the similar size. Example for this kind of defects is sodium chloride, cesium chloride, etc. shows this type of defects, that is Schottky defects. And the other one is Frankel defects. This kind of defects arises due to a vacancy at the cation site, and the cation moves to the interstitial site. So this is known as interstitial position or interstitial site. To maintain the electrical neutrality, one cation enters into the interstitial site. See, here we can observe vacancy in the cation site, and to maintain the electrical neutrality, a cation is entered into the interstitial site, and this kind of defects are known as Frankel defects. And this kind of defects occurs in the compounds which are having low coordination number, which are having ions of different sizes. Suppose if I take example zinc sulfide, silver bromide, etc. shows this type of defects. Now defects in non-stoichiometric compounds, again they are classified into two types: metal excess defects and metal deficiency defects. So first let us discuss about metal excess defects. Again, the metal excess defects are again classified into two types. One is anion vacancy and the other one is extra cation occupying the interstitial space or lattice site. These are classified into two types. One is anion vacancy and the other one is extra cations occupied in the interstitial site. So these two are considered as metal excess defects. So coming to the anion vacancy, this type of defect is arised due to missing of anion from its lattice site, leave it as a hole, and the hole is occupied by an electron. To maintain the electrical neutrality, the hole is occupied by an electron and it is known as anion vacancy. See, in this diagram we can observe that an anion is left from the metal and extra electron occupies it the interstitial site to maintain the electrical neutrality. Therefore, number of positive ions or number of positive charges and number of negative charges are equal. This type of defect arises in the crystals which have Schottky defect. Generally the crystals in which the Schottky defect arises, we can observe anion vacancies also. Example, suppose if I take NaCl and KCl, already these are the examples for Schottky defect. Next one is extra cations occupied at interstitial site. In this case, extra positive ion occupies the interstitial site. See, in this diagram we can observe that an extra cation occupied in the interstitial site, and to maintain the electrical neutrality, an extra electron occupies the another interstitial site. So this kind of defects are known as extra cations at interstitial site. And example for this kind of defects is zinc oxide. Second one is metal deficiency defects. These arises in two ways. One is cation vacancy or extra anion occupying the interstitial site. So the first one is cation vacancy. In this case, a positive ion is missing. See, in the diagram we can observe that a positive ion is missing from its lattice site, and to maintain the electrical neutrality, a nearby positive ion loses an electron and forms a dipositive ion, so that the number of positive and the number of negative ions becomes equal. See, one cation leaves from its lattice point, and to maintain the electrical neutrality, another cation loses an electron and forms a dipositive cation, so that the number of positive and negative ions are same. So this kind of defects can be observed in FeO, ferrous oxide, FeS, ferrous sulfide, NiO, nickel oxide, and DiO, titanium oxide. Next type is extra anions occupying the interstitial site. So in this particular example, an extra anion occupying in the interstitial site. So number of negative ions are more than that of the number of positive ions. So in order to get the electrical neutrality, another cation loses its electron and forms a dipositive ion, so that the number of positive and number of negative ions becomes equal. So this type of defect is not common because the negative ions are usually very large, so that they cannot occupy the interstitial site. They cannot fit into the interstitial site. That's why these kind of defects are very rare. So we can conclude that crystal defects are classified into two types: defects in stoichiometric compounds and defects in non-stoichiometric compounds. Defects in stoichiometric compounds means what are stoichiometric? The compounds maintains the stoichiometric ratio, they are considered as stoichiometric compounds. So the defects are two types in stoichiometric compounds. One is Schottky defect and the other one is Frenkel defect. And the second classification is defects in non-stoichiometric compounds. Again, that means what are non-stoichiometric compounds? If the ions are not maintaining in the stoichiometric ratio, they are called as non-stoichiometric compounds. These are again classified into two types. One is metal excess defects and the other one is metal deficiency defects. Metal excess defects are again two types. One is anion vacancy and the other one is extra cation occupying the interstitial site. Metal deficiency defects are again classified into two types. One is cation vacancy, the other one is extra anion occupying the interstitial site.